Warming in earlier spring increased western U.S. forest wildfire activity.
The article from 2006, Warming in Earlier Spring Increases Western U.S. Forest Wildfire Activity, aims to explain how not only land use history affects wildfires, but primarily climate change. In the West, there has been a drastic increase in wildfires, which we are still seeing today. Most research has shown this is due to how land is treated. Things such as livestock grazing, logging, and much more all shape how land is shaped and wildfire activity, making land drier and more susceptible to fire. Although these human activities do have impacts, that's not all. The major question is climate change affecting wildfires? This study focuses on how climate change is a major contributing factor. This includes things such as early snow melting, droughts, and the increasing temperatures, which make wildfire risk higher. Unfortunately, there is not much research supporting the effects of climate change on wildfires. In the research article, authors look at multiple fires between 1970 and 2003 and look at the hydroclimatic factors that were associated with them. In examination of these fires, authors can provide research and data to try and prevent future disaster fires.
Climate wildfire activity can be affected from moisture levels, drought frequency, warming temperatures, and this can lead to increased wildfire activity or these wildfire risks, as well as climate patterns can affect this from the oscillation in El Nino-La Nina effects. Management or land use wildfire activity comes from livestock grazing and fire suppression, which reduce surface fires. However, the frequency and severity of a forest fire can also come from the accumulation of biomass and forest structure. In addition, historically frequent low-intensity fire regimes with the introduction of these fire suppression systems have prevented frequent fires but leads to more high-severity wildfires because of the growth, and historically infrequent high-severity fire regimes have not been affected to fire suppression. Some similarities between the two include they both have wildfire activity, they both have different fire intensities and frequencies, and they both can interact, causing more intense fires. Some differences for climate have causes such as moisture levels and drought, whereas management, that is fire suppression and logging. Climate has warmer, drier conditions leading to fires, whereas management, that's prevention, natural fires, leads to fuel buildup. Climate, some evidence could be tree ring data or records, and management that may be forest structure or fuel loads. And then the suppression effect for climate, maybe drought and warming reduces moisture leads to fires, and then for management, suppression effect is fuel accumulation leads to high intensity fires.
Methods. The researchers conducted an historical analysis where they collected data of wildfire occurrence, discovery, and intensity in the western United States between 1970 and 2003. They also collected data on seasonal patterns and weather phenomena, such as snowmelt and seasonal temperatures in that same region and time frame, in order to observe any correlation between said phenomena and the rate and intensity of wildfires. A variety of correlational data sets were collected by the researchers, such as spring and summer temperature and wildfire frequency from 1970 to 2003, spring snowmelt timing and stream flow intensity from 1970 to 2003, number of days between first and last wildfire ignition, the number and size of annual wildfires by stream flow intensity, number of wildfires by elevation and timing of snowmelt across multiple years, a t-test of normal distribution between the average precipitation and snowmelt levels between May and October. The p-value was 0.05, and they rejected their null hypothesis that there was a normal distribution. And then the percent of forest vulnerability change in early to late spring season, with the grand majority of them taking place between a percent change of 0.5 to 0.1.
In the mid-1980s, wildfires increased in frequency and duration, going from infrequent short burn periods, an average of 1 week, to more frequent with longer burn periods, an average of 5 weeks. This is due to warmer springs, which decreases winter precipitation and leads to earlier snowmelt. Forests most affected are middle to high elevation forests, which includes the Northern Rockies and Northern California forests. From this study, it was found that climate has a big role in wildfires. It is important to restore vegetation in areas where people live because the land use from humans causes severe ecological impact, which puts these areas more at risk for wildfires. Even so, with rising spring temperatures and earlier snowmelt, areas without history of land use are still at risk, and ecological restoration alone will not be enough to reverse current wildfire trends.
The regional and global implications, there's been changes in forest compositions, meaning species are being moved. Some of these forest areas are turning to grasslands and shrublands. There's been threats to human communities and infrastructures, meaning homes, ecosystems, water supplies are being lost, requiring investments in these fire management programs, ecological restoration, and adaptation strategies. There's been an amplification of climate change effects due to the large amounts of CO2 being released by these fires. There's been this loop where more fires leads to more emissions, accelerating warming and increasing fire risk. And finally, the policies, climate change adaptation strategies. This study underscores the need for the global climate policies as well as local and national efforts to improve the fire management. For the importances of this article, it shows that there's a clear link between climate change and increased wildfire activity. It challenges the previous assumptions on wildfire causes, and it shows that the traditional fire suppression and fuel reduction strategies will not be enough, addressing that the climate change itself is crucial to reducing future wildfire risks.